Welcome to our comprehensive comparison of electric cars and hydrogen vehicles. In this video, we'll delve into the key aspects of both technologies, exploring their power sources, energy efficiency, and refueling times. We'll also discuss other critical factors like range, infrastructure, and environmental impact, helping you understand the pros and cons of each option. Join us as we uncover the current state of each market and what the future holds for these innovative transportation choices. 1. Power sources. Electric cars, often referred to as EVs, rely on electricity stored in batteries as their power source. These batteries are recharged by connecting to the electrical grid, much like how you would charge a phone. This method is straightforward and has gained popularity due to the increasing availability of charging stations. On the other hand, hydrogen vehicles, known as fuel cell electric vehicles, FCEVs, are powered by hydrogen gas. The hydrogen is stored in tanks and used in a fuel cell to generate electricity, which then powers the vehicle's motor. This process is quite different from EVs, as it involves a chemical reaction rather than direct electricity storage. 2. Energy efficiency. When it comes to energy efficiency, electric cars generally have the upper hand. They can convert about 60–80% of the electrical energy from the grid to power at the wheels. This high efficiency is one of the reasons why EVs are seen as a promising solution for sustainable transportation. In contrast, hydrogen vehicles are less efficient, converting only around 30–40% of the energy in hydrogen to power at the wheels. This lower efficiency is mainly due to the energy losses in hydrogen production, transportation, and conversion to electricity. Despite this, hydrogen vehicles offer other advantages that make them an interesting alternative. 3. Refueling, recharging time. The time it takes to refuel or recharge is a significant consideration for vehicle owners. Electric car charging times can vary greatly depending on the type of charger used. Fast chargers can recharge a battery to 80% in about 30 minutes, making them a viable option for quick stops during long trips. However, standard home charging can take several hours, which might be inconvenient for those with tight schedules. In comparison, refueling a hydrogen vehicle is a much quicker process, taking only about 3–5 minutes. This speed is similar to filling up a traditional gasoline car, making FCEVs more convenient for long-distance travel. 4. Range. The range of a vehicle, or how far it can travel on a single charge or fill, is crucial for drivers. Modern electric cars typically offer a range between 150 to 400 miles per charge, depending on the battery size and model. This range is continually improving as battery technology advances. Hydrogen vehicles, however, generally have a range of 300,400 miles per fill, which is comparable to many gasoline-powered cars. This makes FCEVs a compelling choice for those who often travel long distances and need a reliable range. 5. Infrastructure. The infrastructure available for refueling or recharging is a key factor in the adoption and convenience of these vehicles. Electric vehicle charging infrastructure is more widely developed and is expanding rapidly, thanks to both public and private investments. Many EV owners also have the option of charging at home, adding to the convenience. On the flip side, hydrogen refueling stations are less common and are primarily concentrated in specific regions like California, Japan, and parts of Europe. This limited availability poses a challenge for the widespread adoption of hydrogen vehicles. 6. Environmental impact. The environmental impact of these vehicles largely depends on the source of their energy. For electric cars, the emissions are contingent on how the electricity is generated. If renewable energy sources like wind or solar power the grid, the emissions are minimal. However, if the electricity comes from fossil fuels, the carbon footprint increases. Hydrogen vehicles have a different set of environmental challenges. Hydrogen production can be carbon-intensive, especially if derived from natural gas through steam methane reforming. But green hydrogen, produced from electrolysis using renewable energy, can be nearly emission-free, offering a cleaner alternative. 7. Cost. Cost is always a significant factor in any purchasing decision. Electric vehicles tend to be more expensive initially due to the high cost of batteries. However, these costs are decreasing as technology advances and economies of scale come into play. Additionally, EVs often have lower operating and maintenance costs compared to vehicles with internal combustion engines. Hydrogen vehicles, on the other hand, face higher costs for hydrogen production, storage, and infrastructure development. The vehicles themselves are also more expensive due to the complexity of the fuel cell systems. 8. Market availability. The availability of different models is another important consideration for consumers. Electric vehicles have a wide range of models available, catering to different needs and budgets, from luxury to mid-range and economy cars. This variety makes it easier for consumers to find an EV that suits their lifestyle. In contrast, there are fewer models of hydrogen vehicles available on the market. Companies like Toyota, with their Mirai model, Honda with the Clarity fuel cell, and Hyundai with the Nexo, are among the few manufacturers producing FCEVs. 9. Technology maturity. The maturity of the technology behind these vehicles is a critical factor in their performance and reliability. Battery technology for electric vehicles has matured significantly over the years, with continuous improvements in energy density, charging speed, and cost reduction. This progress has made EVs a viable and attractive option for many consumers. Hydrogen fuel cell technology, however, is still developing. Researchers are working to improve efficiency, reduce costs, and increase the durability of fuel cell systems, but it may take time for these advancements to reach the market. 10. Energy storage. Finally, the methods of energy storage in these vehicles are worth noting. Electric vehicles use lithium-ion batteries, which are improving in terms of capacity, weight, and cost. However, the production of these batteries requires rare materials such as lithium, cobalt, and nickel, which poses a challenge in terms of resource availability and environmental impact. Hydrogen vehicles store hydrogen in high-pressure tanks. While hydrogen is abundantly available, the processes for its extraction and storage are energy-intensive, which can offset some of the environmental benefits.